Cassian, part of Instacluster by NetApp. Today, we're going to learn enough to chat about Apache Kafka.
This is the second video in our Learn Enough to Chat About Technology series. If you'd like to see more videos, like and subscribe to our channel. Today, we'll cover what Kafka is, where it came from, how it works, what makes it special, and cover some use cases. Apache Kafka is a distributed publish-subscribe, or pub-sub broker. It allows you to write to and read from streams of events, and this includes continuous import-export of your data from other systems. It also allows you to store streams of events durably and reliably. Finally, it allows you to process streams of events as they occur or retrospectively. Kafka uses topics to sort events, which are written to by producers and taken in by consumers. It is also capable of streaming events, making it very versatile. It's a very highly available and fault-tolerant broker. Its most common use cases are analytics, data streaming, and event-based systems. Next, we'll talk about the history of Apache Kafka. Kafka was developed at LinkedIn and open-sourced in 2011 into the Apache Incubator. It then graduated from the incubator in 2012. The latest stable version is 3.7.0, released in February 2024. Now we'll go into a little bit of how Apache Kafka works. First, we'll cover some terminology. A topic is a category used to organize events. A producer creates and sends events to Kafka for consumption. A consumer takes events from Kafka that's subscribed to and processes them. A partition is a way of breaking down a topic that allows topics to be distributed. Let's talk a little bit more about partitions. Partitions break a topic log down into several logs, allowing a topic to be distributed over multiple disks or machines. It also allows a topic to be accessed by multiple brokers at once. We'll go into more detail about partitions in just a bit. The life cycle of a Kafka event can be seen in this diagram. A producer creates and sends an event to Kafka, which in turn gives it to the next subscribed consumer for polling. The consumer then processes the event. Each event contains data of any type, which is converted into a binary object or blob in order to be written to the Kafka logs. When this data is retrieved, it is converted back into an object when passed using a serialization/deserialization library, or SERD. Kafka handles streaming large groups of messages using partitions. It guarantees that any partition will produce events in the order they were appended. Note this does not mean global order across partitions. This method allows many brokers to read and write to a topic quickly and in succession. Partition keys, which can be generated from any application-specific identifier, like a user or device ID, are hashed to create a partition assignment for each event. In order to create a highly available, fault-tolerant system, Kafka is highly distributed. There's usually more than one Kafka node in a cluster, and these nodes use a gossip protocol to elect a leader, ensure data is correct, and deal with network partitions. Older versions of Kafka, prior to 3.0, used Apache Zookeeper to store cluster information and status data. Now, Kafka uses the internal cluster management tool called KRaft or Craft. Now let's talk about a little bit about what makes Apache Kafka so special. The things that make Kafka special are its high availability and ease of scalability, its performance, the fact that it's open source, and it has a diverse API and support ecosystem. Kafka's architecture and design also play a role. Kafka is, by design, a highly distributed platform. This leads to high availability as the Kafka system, when properly configured and deployed, is able to handle network faults and partitions via its quorum system between nodes. Because Kafka is highly distributed, it is also easily scalable. New nodes can be added to the system without downtime or slowdown. Kafka is extremely performant and can handle large amounts of streaming events in near real time. Couple this with the distributed nature of Kafka and the scalability, and you have a messaging platform that can adapt to many different use cases. Kafka is open sourced under the Apache Software License version 2.0. It is a major project in the Apache ecosystem and has a lot of community support for issues and updates. The API ecosystem for Kafka is a major differentiator. There are many APIs you can utilize in order to get events, streams, transform data, and more. You can move your data into and out of almost any system with the Kafka Connect API. This makes Kafka extremely useful in situations where you have legacy systems that need to talk to newer code. You can use Kafka as a broker between these two sources. You can also migrate data from legacy systems to newer systems using Kafka Connect. Some architectural considerations that went into Kafka that affect these factors include the idea of the simple broker. Topics are the only categorization, and no event data is used by Kafka directly. Because reads aren't destructive, but the log is instead copied, you can replay events when a new group joins or you want to train an ML algorithm. Finally, let's talk about some use cases for Apache Kafka. Most of the use cases for Kafka are very general. That is because it is such a highly adaptable platform. Some common use cases involve event-driven architectures, real-time analytics capture and transformation, and data and event stream processing. Let's summarize what we've learned. First, we learned what Apache Kafka is, which is a distributed, publish-subscribe message broker. Then we learned the history of Apache Kafka, how it started at Facebook and was open sourced in 2011 and is now under the Apache 2.0 license. We covered how Apache Kafka works, including partitions, event and event data lifecycles, and the gossip protocol. We talked about what makes Apache Kafka special, such as its scalability, performance,
extensive API ecosystem,
and its open source
capabilities.
Finally, we talked about use cases, including messaging systems, event-driven architectures, and data processing and streaming. Thanks for watching. If you'd like to see more videos in this series, please subscribe to our channel and please drop us a like.